Hello, in this video I want to compare and explain the pros and cons of these two options. So here, this option here, this is the SDI-12 USB plus analog adapter. So it has 4 channels of high resolution analog inputs besides these SDI inputs. So the pro of this is it is compact. It's just one board that does everything you need. If you don't really need a lot of sensors and a lot of other capabilities, this is one thing that fits your bill. So that is the pro. The con of this board is it doesn't have any expansion port. Right here would be the expansion port of this regular basic SDI-12 USB adapter. That's this expansion port. I can solder these pins on. Right, so this expansion port is missing because there's just no space for it. So that's the con, that you cannot extend this, and this is basically what you see is what you will end up with on this particular adapter for SDI-12 terminals and also for analog inputs high resolution. So that's this. And the other option is apparently to have a basic adapter and stack on top of it this 4-channel high resolution analog input add-on. So you can just basically do that. I think I stacked it. Oh, okay, right here. So the pro of using this is you can extend this. There's actually an address selector here. So if you just had this, it is equivalent to having that. On the software level, there's basically no distinction. You use the same exact commands for these and for those, and the software doesn't really know that you're actually using two different hardware variations. That basically makes things easier. And then if you want more, you can stack more on top, and there are 4 unique addresses, so there you could stack 4 of them. And that is also the con side, is it actually gets a little taller each time you stack something. So this is the full height of a regular adapter, basically, that's stacked on top of it. And there's another one. So it gets a little taller each time you stack. It's not a problem if you are expecting you're trying to connect more sensors, and so you go for a large enclosure, and there should be enough space for all the routing of the wires in the inputs, right? So the pro is you can expand. You can have as many as 4 of these analog input separate extension boards. You can also have 4 to 20 milliamp input boards that I'm actually still prototyping, and you can also have some additional SDI-12 headers stacked on top of it with another extension. And then I'm also working on a possibility of having a GPS module stacked on top, but these are not going to be enough for that. So I'm thinking about using this connector here, this 6-pin header that I use to program that chip. I might be able to use that in conjunction with this to add another adapter as a GPS add-on, which would reduce the cost of having a single GPS unit that I have as a different board. So this basically opens up options, and you can also have this here. So if you choose this option, I'll check all these inputs and make sure they're all working, and then I'll solder this on. And what this can do is you get 2 lower resolution analog inputs. That makes no sense if you're already getting this high resolution analog input. But these 4 inputs are also used as digital inputs. You can sense on and off. You can sense pulses. You can count pulses, and you can add sensors such as raindrop gauges, such as those tipping spoon raindrop gauges, or maybe flow meters that have a spinning, just a little turbine thing that gives you pulses, and you can count how many pulses per a certain period of time, or an anemometer that also does the same thing. Number of pulses correspond to the speed of wind. So this is what this other thing does not have, is having some digital inputs and pulse counters integrated over here. And I've also developed something like this, inspired by one of the users. So this little inline thing can help you connect to a ring gauge, for example, and also smooth out the ring gauge's input, because the ring gauge input is actually a read relay. The relay bounces as the connection is made. So what this thing does is it actually smooths out the bounce. So each tipping of the spoon corresponds to a single transition between low and high, high and back to low, instead of multiple. So this gives you accurate counting, and you can add this to multiple of them, and that depends on what you need. Maybe you have a ring gauge, you have an anemometer, and then in 2 other channels you can leave them open, right? So this is another option where you can expand, but the physical dimension will get bigger as you do. And this one here, back here, is you cannot expand, but this gives you all that you need. If you just need up to 4 high-resolution analog inputs and up to 4 SDI-12 sensor connections. So this is a very compact system, and so that's the pros and cons. They cost about the same. Basically, I think they cost exactly the same without this option here. And so it's up to you, the project that you're planning on. You can choose between the two. I hope this video helps. Thanks.